In this lecture, we will discuss about correlation and regression. What is correlation? How to calculate correlation? What is regression? What are the types of regression? How to find x if given y? How to find y if given x? And a little more computations. First of all, it is correlation and regression. This is correlation. Co means it's two. The relationship between two variables. We can take this. As a meaning in a funny way. Okay. So suppose given x and y, two set of values. X and y, the two set of values. If x increases, what may be the change in y? Or if y increases, what may be the change in x? That's the primary question in our mind. And see now, it is this is x-axis and this is y-axis. Let's plot our points on x and y. It is this one x and this one y. Okay. Let us plot our x and y points. It may be like this and fit a line which will be like this. Okay. Suppose take a point from here and this will be the x and y point. Say for example this will be 2, 3. And take another point over here. And this point may be some 20, 40, right? So the x value is 2 and here the x value is 20. Here the y value is 3 and here the y value is 40. See, as x increases from 2 to 20, y is also increasing from 3 to 40. And hence, as x increases, the value of y is also keep on increasing. And hence we can call it as the positive correlation. That is, the correlation between the variables x and y is positive. As x increases, which induce the increasing the another variable. Consider the next one. If the values of x and y is like this, and if we fit a straight line like this, take a point over here which will be for example 2, 40, right? So this value will be 2 and this y value will be 40, and here take another point from here and this may be take this point as some 20, 2, right? So this x value will be 20 and this y value may be 2. Hence, as x increase from 2 to 20, y tend to decrease from 40 to 2. See, x increase from 2 to 20, whereas y decrease from 40 to 2. And hence we can call it as the negative correlation. So, if we are unable to fit a straight line and if the value is like this, that instead of going here, if it is like this, then we may call it as a no correlation. That is, we are unable to fit any straight line for the particular data. There are no correlation. Let us notate this correlation by R. So the positive correlation lies from 0 to 1. The negative correlation lies -1, less than or less than 0. And no correlation, it is very obvious, R is equal 0. Okay, now see. So from these graphs, we understand that the correlation coefficient R always lies between -1 to +1. And it can be 0 also. Now the question is, what may happen if there is a equal to? If R is equal to +1, we call it as perfect positive correlation, and if r is equal -1, we call it as perfect negative correlation. It is negative correlation. Now we are going to discuss a problem from the correlation. The height and weight of 10 students is given below. That is, the height and weight of the 10 students is given below. That is, we have to find the correlation between the height and weight, so that we will came to know if height increases, whether weight is also increasing, or will it be in the vice versa, or there may be some surprising some other results. Okay, in order to do that, we have to calculate a little more items. Before that, let me write the rule, the formula for correlation coefficient. For correlation coefficient R, the formula is n into summation xi yi minus summation xi into summation yi, the whole divided by square root of n into summation xi square minus summation xi whole power 2 into square root of n into summation yi power 2 minus summation yi whole power 2. So from this rule we came to know, see, we need xi into yi, the product, summation xi into summation yi, so we need the summations, and xi power 2, and here it is yi power 2, and hence let us take this heights as xi's and weights as yi's. So since we need to do by using this rule, we have to find xi power 2, yi power 2, and xi into yi. Xi power 2 is xi into xi, so 71 into 71. This is 70 into 70, 64 into 64, 61 into 61, like that. And yi power 2 is 69 into 69, 62 into 62, 80 into 80, 58 into 58, like that. And finally this is xi into yi. In xi into yi is the product of this height and weight. This is 71 into 69, 70 into 62, 64 into 80, like that. So let me write the values: 50414900, 5476372142254900, 3969, 29164761 3969 and 3600, and for YA it is 4761 3844 6400 3364 4356 5625 1764 4624 4900 and 3025, and this is 4899 4340 5920 3538 4290 5250 2520 4284 4830 2970. And after calculating this, let us find the total also. The total of xi is summation xi, the total of yi is summation yi. This is the total of xi power 2 summation xi power 2, the total of yi power 2 summation yi power 2, and this is xi yi, so summation xi into yi. Let us find the totals. This is 657, this is 645, this is 42841, this is 4, I'm sorry, this is 43509. This is a 42663, and this is a 42841. And we know that the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The height and weight of 10 students is given below, and hence n is also is equal to 10. Just substitute all these values, summation xi, summation yi, xi power 2, yi power 2, and the value of n in the associated rule that what we have for correlation coefficient. In place of n it is 10. Summation xi into yi, this is 42841 minus summation xi, this is 651, summation yi, this is 645, the whole divided by square root of the value of n is 10, summation xi power 2, summation xi power 2 is 43509 minus summation xi is 657 power 2 into a square root of n is 10 into summation yi power 2, summation yi power 2 is 42663 minus summation yi is 645 power 2. So just do the manual computation or using your calculator, just to find the value of a correlation coefficient, which I found that is 0.77. And thereafter it is the coefficient of determination. The coefficient of determination is given by r power 2, whereas we found this r as 0.77, so it is 0.77 power 2, which is equal to 0.5929 as the solution. Okay, let us continue the regression equations, the regression coefficient for the same problem, whereas there is no need for these values, since we are going to use such a rule, such a formula for finding the coefficients and the equations. Hereafter we are going to consider only the totals for finding the regression equations and the regression coefficients. Now in this problem we are going to find the regression equations. For regression equations, see in the table of data, I just deleted all the items, all the data and everything except the summation. I noted this summation, that is summation, the summation xi, summation yi, summation xi power 2, summation yi power 2, summation xi yi, the correlation coefficient I found which has been denoted by r, and the value of n I have simply noted. From this we will calculate all the rest. So now let's calculate the regression coefficients. The regression coefficient of x on y. The regression coefficient of x on y, that is, it is denoted by b. This is x on y, so it is xy is equal n into summation xi yi minus summation xi into summation yi divided by, this is xy, so y is in the second part, so better write this y in the denominator. So it is n into sigma yi power 2 minus sigma yi whole power 2, which is equal to, the value of n is 10, summation xi yi, the summation xi yi, the value is given by 42841 minus summation xi into summation yi, that is 657 into 645, the whole divided by, it is the value of n is 10, summation yi power 2, summation yi power 2 is 42663 minus summation yi is 645 whole power 2. After a little manipulation you will be getting 0.44. And say the rule for byx, the correlation coefficient of y on the variable x, which is n into summation xi into yi minus summation xi into summation yi, the whole divided by n into summation the x is in the second part, and hence it is summation xi power 2 minus summation xi whole power 2. Just to substitute the values of n summation xi, we see the numerator is same, and the value of n summation xi power 2 minus summation xi 657 whole power 2 over here, and after doing a simple manual work we will be getting 1.35 as the solution for byx. And the next, finding correlation coefficient R from the regression coefficients. There is a rule behind that. The correlation coefficient R is equal plus or minus square root of bxy into byx is equal plus or minus square root of bxy. The value of bxy is 0.44 into the value of byx is 1.35, from which we will be getting 0.77, as we already have calculated this R through a huge calculation. And if we know the values of bxy and byx, that is the regression coefficient of x on y and y on x, we can also calculate the correlation coefficient from that. And see, here it is mentioned plus or minus. If both the values of bxy and byx or plus, then we can consider this as a positive correlation, and if both the values of bxy and byx are negative, we can consider this as a negative correlation. And 1 plus 1 minus, that is bxy is plus and byx is minus and vice versa, it's not applicable since within the square root we are unable to take any negative values, which leads to the imaginary number, the complex value function, but whereas we are here discussing only the real valued functions and the real values. This is the correlation coefficient, and now it is to find the regression equation of x on y. The regression equation of x on y. See, this is x on y. So this is x minus x bar is equal b x on y. So this is xy. It is on y. So it is y minus y bar. Where this x bar and y bar is the averages of x and y separately. So now we have to find the averages. X bar is equal summation xi divided by n. Summation xi is given by 65.7 divided by 10, which is 65.7, and y bar will be given by 645 divided by 10, which is 64.5. Substitute those values, so it is x minus the value of x bar is 65.7 is equal bxy, the value of bxy is 0.44 into y minus the value of y bar is 64.5. Since this is the regression equation of x on y, try to express this as x is equal to, so this is x is equal to 0.44 into y minus 64.5. Take this here, it is plus 65.7. And in a similar way, we can find the regression equation of y on x. Y on x. Since the equation is of y on x, put it as y minus y bar is equal b. This is y on x, so yx into x minus x bar. So this is y minus the value of y bar is nothing but 64.5 is equal byx. Byx is given by 1.35 into x minus x bar. The value of x bar is 65.7. So since this is the regression equation of y on x, try to express this in terms of y, that is take it as y is equal to this is 1.35 into x minus 65.7. Take this number here, so this is 64.5, which is the equation, the regression equation of y in terms of x. Okay, so let's continue with the same regression equations. Let's find the value. If we are given the value of x, how to find y, and if we are given the value of y, how to find x. That is predict the value of x. Let me delete over here. So this is the regression equations and everything. So just write the value of bxy, this is 0.44, and byx is equal 1.35, and x bar is equal 65.7, and y bar is equal 64.5. Okay. Suppose if we are given x is equal 72, find the value of x. That is, find x if y is equal 72, and find y if x is equal to 68. See here the point is, this is find x if y is equal 72. So we have to take the equation x and y. That is, we have to take the equation where we are having x is equal to. This is to find the value of y. So we have to take the equation from which we have y is equal to. So we have to take this equation. So let us substitute y is equal 72 here in order to find the value of x. So x is equal 0.44. In place of y it is 72 minus 64.5 plus 65.7, in which we will be getting around 69, and the value of y if x is equal to 68. So substitute in this equation, that is y value equation. So it is y is equal 1.35 into, in place of x it is 68, in place of x it is 68 minus 65.7 plus 64.5, from which you will be getting it's around 67.61. See, while starting the problem, we assume that the x's are height and y's are the kilograms, that is in terms of weight. So let us note this x is 69, so which explains that if y is equal 72, that is, if the weight of a corresponding student is 72, the approximate height of the student should be 69 inches. 69 inches. Centimeter is not at all possible, right? That is a logical error. And if the height of the student is 68 inches, the weight is around 67.61, which is around 68. Okay, this is the result of the regression equations of x on y and y on x. So in this problem we have discussed how to find the correlation coefficient from the regression coefficients and the regression equations of x on y and y on x. The values of y and x are given, the values of x and y separately. We will be meeting in the next lecture. Thanks for listening. Meet you. Bye bye.